Hello everyone. This is the second video for your Unit 3 Linear Functions unit. Now I'm going to start on this page where these other examples you could go back and do after I explain what's going on here. So we're going to start off without a application. We're just going to start off with some data and create our own application and create the model. Okay, so here we go. We have 3 data points. Notice how they are not in ascending order. 5, 0, 10. The way we've been writing these previously, this one would have to be here and the 5 would be next. It doesn't matter what order they're in, but it just matters what order you do the slope formula in. So the slope formula is y2 minus y1 over x2 minus x1. So I'm going to do y2 minus y1, 25 minus 35 over 5 minus 0. All that matters is that these numbers correspond and these numbers correspond. We get negative 10 over 5, which is negative 2. So the slope is negative 2. So our function, f of x equals negative 2x, and our y-intercept is listed right here. So when x is 0, f of x has to be 35. So there's our equation of the line. If I didn't see that right away, I could call this y and this x, plug 5 in for x, 25 in for y, and then solve for b. Create a scenario to represent this linear function. So you could say you start with $35, a soda costs $2, costs $2.50. No, it costs $2. It has to match my rate of change. And a soda costs $2. So now the input variable is my input. My x value represents the number of sodas. My units are going to be ones, right, per soda. My domain is going to go from 0 till how many sodas can I buy? I can only buy 17, because if I buy 17, 17 times 2 is 34. I have $1 left over. My output variable is money left. The units is in dollars. And the range goes from the smallest amount of dollars I have left is 1 and goes to 35. So as I come down and graph it, if I let this represent x and this represent f of x, I would start off with 2, 4, let's call this per $5. So every line represents $5. So 5, 10, 15, 20, 25, 30. There's 35. So if I've bought 0 sodas, I have $35. Then I come all the way out here to 17 sodas, and I'm still going to have $1 left. So here's my graph. So notice there's no arrows on the graph itself because it stops. So my domain is from 0 to 17, and my range is from 0 to 35. All right. Identify the x-intercept. There is none, because we have $1 left. So it never actually crosses the x-axis. So identify the x-intercept, there's none. Identify the y-intercept, well that's 0.35. No sodas purchased. Alrighty. So this assignment in my math lab is called intercepts that corresponds to this. intercepts that's due 7/3 at midnight. And it does have a by hand portion. That's one question that you'll have to turn in to me, and I'll show you how to do that again in the next couple questions. So you'll do the same thing a few different times. Now let's look at a model. A model is a mathematical representation of the essential aspects of an existing problem. A model is useful because we can use it to predict the future. We can use it to understand the problem on a different level because of the relationship between the input and the output. These are the steps for creating a linear function. So for the two assignments that are due, the modeling with linear function, then I'm going to have you fill out answer three more applications. You're going to basically answer these questions in a Word document and then copy and paste an Excel graph in. So what I'm going to do is I'm going to answer question, let's do this one. Let's do practice 2. I'm basically going to fill it out using Word and Excel to kind of give you a model of what I want from you. Okay? So now let's open up a Word document. So these questions, notice down here at the bottom, it says choose 3 of the application problems on page 18. Complete one template like page 19 for each. So I'm basically modeling what you have to do for these templates. Okay? But I'm not going to do any of these 7 problems. I'm going to do this problem. Alright? So my name, put your name, and then call it, give it a title. Alright. So then question 1. Identify the independent and dependent variable. The independent, which is fine just to call it that, is, in this case, is Fahrenheit. Degrees in Fair, Fahrenheit, and your dependent is degrees in Celsius. So there's my independent and dependent variable. SIU. Alright. So now question 2. So answering the questions on your template. So number 1 says read and understand the application, which we already did, so this needs to be question number 2. Then you can come in here and define. Okay, question, define the independent and dependent variables. So this is going to be, so this is F, and this one is C of F. Alright, question 3 says, determine the domain and range. So I'm not going to do that yet, I'm going to wait to graph it. So here's, I'll put the domain and the range. Number 4, create a table of values and create a graph. So the table of values, you don't necessarily have to create and print, because you'll do that whenever you create your graph. So now let's go back into Microsoft Excel. So this is going to be F, and this side's C of F. Let's jump back in here. Let's read the question. Okay. In chemistry class, you have to convert Fahrenheit temperatures to Celsius temperatures for an ongoing lab experiment. The conversion formula is a linear function C of F, here it is, where F is the temperature in Fahrenheit and in Celsius. All right. So we have to determine what values we want to graph in between. So I'm basically going to graph my Fahrenheit values from -100 maybe up to 300. So when F is -100, what is Celsius? We'll plug it into this formula. So -500 minus 160 divided by 9. So it's -73.3. So there's your first data point. -73.3. What about when it's 0? When Fahrenheit's 0, what's Celsius? Well, Celsius is -160 divided by 9 because F is 0, so this part goes away. -17.8. Now let's do when Fahrenheit's 100. So 500 minus 160 divided by 9. 37.8. Now you can keep going if you wanted to. But what I'm going to do is graph these 3 points by doing insert, scatter, and then always go to layout 9. Delete. Delete that off. Notice, does this graph match, does this function match our function? Not really. Ours looks a little bit different. How come? Well, this has 0.5555 for the slope. Ours has the slope of 5/9. Well, what's 5 divided by 9? Well, look, it's 0.55555, so that's where this slope comes from. Where's this -17.767 come from? Because we have -160 over 9. Well, let's try it. -160 divided by 9 is 17.767. So that's where these values come from. Chart title, this is temperature conversion. Enter. Down here is Fahrenheit. And over here is Celsius. And that's it. Then you click on the chart, you go Control C. Go back to your Word document. Call this 4 and 5. And go Control V. Copy and paste the graph in. So now I've answered part 4 and 5. Or part 4 actually, that's not part 5. Part 4 is one question. So another number. Number 5 says, using the table and graph, determine the slope, x-intercept, and y-intercept. So your slope, tell me what it is. 5/9 or 0.59, right? 5 divided by 9. And then tell me what your y-intercept is. So in this case, it's the 0, 17.7.8. Your x-intercept. So the x-intercept, let's think about it. The x-intercept is here whenever the Celsius is 0. When Celsius is 0, that's freezing. Freezing is 32 degrees. Oh, this is 0, -17.8. That's right. So 32 degrees is 0 degrees Celsius. So there's our x-intercept. Interpret the slope and y-intercept. and go on from there. So then answer question 6. Right click, continue numbering. So answer question 6, interpret the slope. So the slope is basically one half a Fahrenheit degree, 1/2 a Celsius degree is a Fahrenheit degree. And answer these questions in your Word document. So you're going to fill out 3 of these out of these 7 applications. So pick 3 of these 7 applications. Remember, when you're dealing with time, you want to call the first year 0. Like it says here, make T the number of years since 2002. So let 2002 be year 0. So you're going to fill out 3 of those, and you have some modeling problems in MyMathLab. So this one is in MyMathLab. So you have with intercepts and this modeling with linear functions, you have homework to turn in. Create it in Microsoft Word, email it to me, save it in email, and then you also have these 3 application problems. So you have 3 assignments that you need to email to me, just created in this video. Your next video will cover inverses. So before you watch the next video, you'll have to do this pre-class assignment, function notation and slope-intercept form. Notice this next video I make will be the last video before your Unit 3 linear functions exam that's due July 6th. Thank you everyone, and have a wonderful day.